All right, now we're cooking. Now we're falling into one of those sections that I actually like. All right, let's talk about relations and functions. So, pretty simply, a relation is a set or a collection of ordered pairs. And you can see that I've got an example here. I'm using this set notation right here. And I've got 5 different ordered pairs listed. That describes a relation. Okay, a relation is just a connection between x and y. You may not know what it is, or there may be a formula behind it, but it's just a relation. It's just a connection. It could be, you press this button and you get that piece of candy, or this is somebody's name and this is their birth date, or this is the number on someone's jersey and that's the player. Some kind of connection. That's all that means. It could be something like this, where you have an infinite number of points that make up a relation. And so you have this continuous graph right here. And you have an infinite number of points. So I'm not going to list those out for you. Now, when we talk about relations, we also talk about domain and range. So that's why I left a little bit of space here, because I'm going to come back to that. So when we talk about domain, this is the set. It's the set of x values used in the relation. That's all it is. The domain is the set of x values used in the relation. And then we have the range. And the range, likewise, is the set of y values used in the relation. So let's talk about what that is. So up here for this one, let's talk about what my domain is. Now, since I have discrete points listed, when I talk about my domain, I need to use the set notation, a little curly bracket. And I'm going to list just my x values, and that's it. Now, I tend to write these guys in order because that's the way I like to work. So when you put these guys in order, you would have -3, and then you have 0, you have an x value of 1, and you have an x value of 7. So that's how we would describe the domain. Now, some of you may say, wait, but you've got 1 twice. Do you need to write it twice in your domain? And the answer is no. When you write domain and range, you just need to indicate, are you including that value? I'm including 1. How many times? Don't care. All that this is showing is that you are including it and it's part of your relation. That's all. Your range is just the set of y values. So again, we have discrete points, so we need to use the set notation for that. So if I try to order those y coordinates, let's say I think -5 is the least one. And then we go to 2, and there's 3, and there's 4, and 2 is repeated, right? You see two different spots. But again, I only need to write it one time. When you have graphs, these guys most of the time are on this continuous spectrum. So when you describe their domain and range, you're going to use interval notation. So for this guy right here, his domain, as you go from left to right, he's going all the way left. He goes all the way right. There are no gaps, there are no breaks. And so you would say all real numbers. So from -infinity to infinity. And what about the range? Well, the range is going to go all the way down, all the way to the top, right? So when you look at this, he goes all the way down, he comes up, he curves back, but then he ends up going up all the way. There's no stopping that guy, so it goes all the way down, all the way up. So he is going to need to use every value that's on that spectrum for y. All right, so that's domain, that's range. Now we want to talk about what it means to be a function. Okay, so a function is a relation where each value in the domain is paired with only one value in the range. Okay? So a function is going to be a relation. It's a subset of relations where each value in the domain is paired with just one value in the range. So let's look at this first example that we had. Okay? Is each x paired with just one y? Well, you can look at this, but then you're going to notice there's a problem. And the problem happens right here. See, 1 corresponds to 4. Think about this like a vending machine, right? You press one button and you get out one item, right? Because each button or each button combination is paired with just one item. You go to the soda machine, right? You press one of those buttons and you're going to get a Coke or a Sprite or whatever it is, but you only get one of those, right? This guy's saying you pressed 1 and you get 4, but you could also get 3. And that's not the way functions are supposed to work. You plug in 1, you get out 1, right? So this guy up here, this is not a function. If you go to your calculator and you start typing in numbers, all right, let me grab my calculator here, and you're going to see this guy is a function. Let me show you. If I type 5 times 4, I get 20. If I type 5 times 4 again, I still get 20. Because this is going to act as a function. You type in one thing, you get out one answer. Now, is 5 times 4 the only way I can get to 20? Well, no, because I could do 18 plus 2. So the output is not necessarily unique to that input. There may be other ways to get there. But for each input, there's only going to be one output that's associated with it. So this guy's not a function because I could plug in 1 and I'm getting 2 different answers out. Not a function. What about a graph? How do I know if a graph represents a function or not? It might be kind of hard to see because you do have an infinite number of points here. But we do have a trick that helps us out, and it's called the vertical line test. All right, the vertical line test. And here's what this says. It says that for a graph, to represent a function, every vertical line must cross it in at most one point. So in order for a graph to be a function, no matter where you put a vertical line, you can only cross it at one point. Okay? So if you have a ruler or a pencil, you just kind of slide it along vertically and you see if it ever hits more than one point. So if I take this guy and I slide it along, is there ever a time when that guy is hitting more than one point? And the answer is no. You can draw vertical lines wherever you want to, and you only ever hit this graph in one spot. You know it's going to be bad and not a function if the graph ever curves back on top of itself, or if it's ever layered, if it's ever stacked. That's going to fail the vertical line test, and it would not be a function. So this one right here is a function. Okay? So what we're going to do in these next videos is I've got several examples, several pictures that we're going to run through, and we're just going to determine whether or not it's a function, and then we're going to determine the domain and range. So stick around.